Hello and welcome. This is going to be our homework help video for the Unit 3 Quadratics test review. First, let me talk a little bit about our number types up top here. The most important part about number types is that in order to expand number types, you have to add in additional elements. In order to expand the number type of counting numbers to whole numbers, you have to add in 0. Another important thing to point out, irrational numbers is not one of our all-including number types. Real number is the all-including number type that includes both rational and irrational. So, an integer is not considered irrational just because irrational is further out in the ring. Integers are considered real irrationals, that's what's getting added in. Same thing with imaginary numbers. Those get added into the real numbers to make our complex numbers. Imaginary numbers, there's really only the one that we have to worry about, and that is I. I is the square root of -1. And by using I, we can express all sorts of other square roots of negative numbers by just kind of splitting them into an I and a real radical. So this becomes I root 5. And so imaginary numbers, it really should just be the 1 is all that's in that group. But when we add it into the real, we get the complex. But yeah, I do encourage you to actually go research some definitions for these. Try to find something that you can understand and connect with. Let's go on to some actual problems where we got to show some work. I'm going to go to problem 10 because I'll have to convert it to vertex form, so that'll kind of cover problem 9. What I'm going to do is I'm going to, first I'm going to copy it down. Next I'm going to rewrite it in the structure of vertex form, and we know that structure has a binomial squared. This number here in that binomial is always half of our b value. Now before I even did this, I should have checked that my a value is 1. It is. So this is why I'm able to do this. If it's not, you have to divide or multiply to get an a value of 1. All right, so this x plus 4 squared will get me an x squared back. It will give me an 8x back. It's also going to get me 16, so I'm going to subtract that away. I'm going to keep that plus 13 though. So now I've got y equals, once I combine my like terms, the quantity x plus 4 squared minus 3. This gives me a vertex of -4 comma -3. Let's go to that point. Over 4 down 3. There's my vertex. Now my a value is 1, so I can just use this pattern here. 1, 2, 3 goes to 1 squared 1, 2 squared 4, 3 squared 9. If there was an a value, I'd have to multiply all of these by that a value. Okay, so if I go 1 over from the vertex, I'm going to go 1 unit up. That's where this one comes from. If I go 2 units over from the vertex, I'm going to go 4 units up. So 2 units over, 1, 2, 3, 4. And if I go 3 units over, I'm going to go 9 units up. I'm off the graph at that point. Let's just make this symmetrical over our vertex and connect them up with a solid line. Arrows at the end to show that it goes on forever. All right. Equation of a parabola in standard form that has a vertex. I'm just going to go ahead and label that HK 6, 13 and a y-intercept of 85. The y-intercept gives me another point that this goes through. It goes through the point 0, 85. So that the y-intercept, the x value is always 0. Let's plug this all into vertex form. Y equals a times x minus h squared plus k. Y, I'm borrowing, this is x and y. I'm going to borrow an 85 from my y. A, I don't know yet. X is 0. H is going to be 6. And k is 13. Simplify this a little bit. I've got 85 equals a times -6 squared is 36. Maybe I should have subtracted 13 from both sides so I can save a little room here. Let's subtract 13 from both sides right now. So 72. Now I can divide both sides by 36. And I get that a equals 2. So I borrowed an x and a y. I've got to give them back. But the h and the k values stay. Where should I write this? Off to the side. We'll just put it down here. Y equals a, 2, times x minus h, 6, squared plus 13. But it asks for standard form. So we got to convert vertex to standard. That just means foiling this binomial and then combining like terms. So that's going to give us an x squared minus 12x plus 36 plus 13. Y equals 2x squared minus 24x plus 72 plus 13. Y equals 2x squared minus 24x plus 85. There's our equation in standard form. Write the equation of a line that goes through the following 3 points. You can use regression or matrices. Let me just set up the matrix for this first one. You can solve it if you want, but then I'm going to do regression for the second one and actually solve it. The matrix is always an x squared, an x, a 1, and a y's column for each point. So 36, negative 6, 1, 140, 1, negative 1, 1, 15. That's for our second point. And 1, 1, 1, 21 for our last point. Use matrices if you want, but I'm okay with you doing it with regression, which I think goes a little bit faster. So that's what I'm going to focus on right here with problem number 13. Let this boot up. First thing, I need to get that data into the calculator. So I go stat, enter to open up my stat lists. Clear out any old data. And put in my x values, negative 2, 1, 5. Put in my y values, 3, 30, and 38. Then I'm going to go stat again, over to calc, and then run a number 5 quadratic regression. No need to store the equation, let's just calculate it, get our a, b, and c values. So a is negative 1, 823, let's see, negative 1, 823. Y equals negative x squared plus 8x plus 23. And that's that equation for that one there. Let's go look at the back side. The back side, we're being asked to solve some equations by factoring. We need to get these into standard form in order to be able to do that. First step of getting number 14 into standard form would be to add 35 to both sides. P squared plus 12p plus 35. And then I ask myself, what two numbers multiply to be 35 but add to be 12? That is 5 and 7. And then zero product property will get you p equals negative 7, p equals negative 5. I set these each individually equal to 0 and solve. Hopefully we're okay with me doing that in one step. All right, let's look for one that we need to do factoring by grouping. Like 16 looks like a good one. I'm going to subtract 3 from both sides. I'm going to get 3k squared minus 5k minus 12 equals 0. None of these share a common factor. 3 and 5 are both prime, so I know I've got to do factoring by grouping. So I'm going to multiply the first and the last terms, the 3 and the negative 12, off to the side. Again, negative 36. And then I need to split that into two values that multiply to be negative 36, but add to be a negative 5. I'm thinking, let's see, 12 and 3 is too far apart. 6 and 6 is not going to work. If I'm struggling to come up with this number, I can, in my calculator, do negative 36 divided by x in my y equals, and then go second graph. To scroll through, I might go to second window to have this start at 0. Then second graph and scroll through to find two factors that add up to negative 5. I think I see them right there, 4 and negative 9. Now I want to put the negative 9 on the same side as the 3, so when I split this, so I've got 3k squared minus 5k minus 12 equals 0. I'm going to split that negative 5 into a negative 9 and a 4. That way the negative 9 will be with its common factor of the 3. So negative 9k plus 4k, 12 equals 0. And now I'd take the greatest common factor out of the first two terms and the greatest common factor out of the second two terms. Greatest common factor of the first two terms is a 3k, leaving behind a k minus 3. Greatest common factor of the second two terms is a 4, leaving behind a k minus 3. These two things we took out combine to make their own linear factor. And then we only need one copy of this identical linear factor here. And I'm going to set these each individually equal to 0. 3k plus 4 equals 0. K minus 3 equals 0. Plus 3. K equals 3. That's one of our answers. Minus 4 minus 4. 3k equals negative 4 divided by 3 divided by 3. K equals negative 4 thirds. For number 16. See if that's right. 16, negative 4 thirds, and 3. All right, completing the square. To do this, as soon as I've got an a value of 1, I can convert my quadratic, my linear term, into a binomial squared, always cutting the b value in half when doing this, and then subtracting the extra. In this case, the extra would be 10 squared or 100. Let's keep the minus 78. Let's keep the negative 9. I'm going to add 100 and I'm going to add 78 to both sides. That's the same as just adding 178. And now I get x plus 10 squared equals 169. Take the square root of both sides. I'll get x plus 10 equals plus or minus 13. Subtract 10 from both sides, and I'll get x equals 10 plus 13, or negative 10 plus 13. X equals negative 10 minus 13, giving me my final answers of 3 and negative 23. Quadratic formula. I guess I could do one of these really quick. Let's add 5 to both sides. 4n squared plus 5 equals 0. My a value is 4. My c value is 5. B is 0. So negative b plus or minus the square root of b squared minus 4ac all over 2a becomes plus or minus the square root of negative 4 times 4 is negative 16 times 5 is negative 80 all over 8, which I believe just is plus or minus square root of 80i over 8. This could be simplified. The answer key is going to have it simplified, but you can just leave it like that. Yeah, they can reduce that down. But I would accept this as well for problem number 20. Sketch the graph of each function, quadratic inequalities. All right. I think we've completed the square enough. I'm going to go for the easier one, 23. This one's got a vertex at 1, -4, so 1, -4. It goes up, and it's got an a value of 3, so 1, 4, 9 is going to become 3, 12, 27 when I multiply them all by 3. So I go over 1, up 3. Over 2, up 12. That'll take me all the way up to 8. Now I'm going to intentionally connect them with a solid line. No, we generally do solid lines, but I know that it's solid for a reason here. It's because it's got the or equal to. And this is a less than, so I'm going to shade below this. I'm going to shade kind of out here on this guy. And that represents all of our combinations of x and y that make this true. All right, let's do a systems problem and then get out of here. I guess problem 24 maybe looks a little more challenging. We'll do that one. All right. For problem 24, I need to definitely solve the second equation for a variable. Maybe subtract 2x from both sides. We'll get y equals negative 2x plus 3. And then I got to plug that in for y both here and here. Take a look at what that looks like after we do that substitution. I'll get an x squared minus 4 times the quantity negative 2x plus 3 squared plus 46x plus 2 times negative 2 plus 3, negative 2x plus 3 minus 90 equals 0. X squared minus 4 times negative 2x plus 3 times negative 2x plus 3. That's what the squared means. I gotta rewrite the base twice. Plus 46x, distribute in this 2. We get minus 4x. Get rid of this. Plus 6. Minus 90 equals 0. We now need to FOIL those binomials. So first, outside, inside, last. And let's go ahead and combine some like terms as well. That's going to give us x squared minus 4 times 4x squared minus 6x is going to be a minus 12x plus 9. Combine these, we'll get a plus 42x. Combine these, we'll get a minus 84 equals 0. Let's go ahead and distribute this 4 in. And we'll get x squared minus 16x squared plus 48x minus 36 plus 42x minus 84 equals 0. Let's do some more combining of like terms. And we'll get negative 15x squared. Combine these, we'll get a plus 90x. Combine these, we'll get a minus 120 equals 0. Everything here is divisible by negative 15. And let's see, if we divide by negative 15, we'll get x squared minus 6x plus, that is 8, I believe, equals 0. This can be factored into x See, two numbers multiplied to be 8, but add to be 6, -6, -4, -2. So x minus 4 equals 0, x minus 2 equals 0, x equals 4, x equals 2. So we're not done. We got to plug those back into our linear. Y equals -2x plus 3. And so when I plug in 2, I get y equals -2 times 2 plus 3. Y equals -4 plus 3. Y equals -1. This gives me the ordered pair 2 comma -1 as one of my solutions. And when I plug in a 4, I'll get -2 times 4 plus 3, y equals -8 plus 3, y equals -5, giving me the ordered pair 4 comma -5. Let's just see if we got that right. 2 comma -1, 4 comma -5. All right, so that's that for this review video. Hopefully that's been helpful. Don't forget to check out the other videos as you study for the test.